Assume that Friday morning taxi cab rides have times with a standard deviation of 9.6 minutes. A cab driver records times of rides during a Friday afternoon time period and obtains these statistics. N equals 16, the sample mean is 18.1 minutes, and the sample standard deviation is 12.2 minutes. Use a 0.10 significance level to test the claim that these Friday afternoon times have a greater variation than the Friday morning times. Assume that the simple random sample has been selected and the distribution is normal. So the two requirements have been met. It's a simple random sample and it's normally distributed. So now we can set up our hypotheses. Let sigma denote the population standard deviation of Friday afternoon times. So sigma represents the population standard deviation of Friday afternoon cab rides. And we're testing the claim that the Friday afternoon have greater variation than Friday morning times. And Friday morning times, the standard deviation is 9.6. So we're comparing it to 9.6. So for the null, we always assume that it's equal. And in the alternate, the claim is that it's greater than 9.6. Okay, so now we can use StatCrunch to test this claim. So since we're testing a claim about variation or population standard deviation, we can use variance stat. One sample, we don't have the data, we have the summary. So let's go ahead and enter our sample variance. So the sample variance is actually not given, but the sample standard deviation is given. It's 12.2. So I can take the sample standard deviation and raise it to the 2 power, which turns into a variance. So that becomes a variance. Sample size is 16, and we're doing a hypothesis test. In StatCrunch, we're doing it for variance. So we're going to have to square both sides. So in the null, we're saying variance is equal to 9.6 squared. So make sure you change these to variance. So we're going to square everything. And in the alternate hypothesis, we're saying that variance is greater than 9.6 squared. We can click on p-value plot to see the graph. Let's click compute. There's the test statistic and the p-value. And it's a right tail test. This is our p-value, and this is our chi-square test statistic. So rounded to 2 decimal places, it's 24.23. And the p-value rounded to 3 decimal places, 0.061. And we have to write a conclusion. So again, p-value, if p-value is less than equal to significance level, we're going to reject the null. If p-value is greater than significance level, we're not going to reject the null. So in this case, our p-value is 0.061 and the significance level is 0.10. So our p-value is less than significance level. So we're going to reject the null hypothesis. So we're rejecting the null hypothesis. That means we have enough evidence to support the alternate hypothesis that claims that the variation is greater than 9.6. So there is sufficient evidence to support the claim that the Friday afternoon cab rides have a greater variation than Friday morning.